Hi, my name's John, and this is the effect of increasing phosphorus concentrations in sodium alginate hydrogels on the germination rate of radish seeds. So, as an intro, phosphorus is a micronutrient plants need for germination as well as further down in life for metabolism. And sodium alginate is a typical hydrogel polymer used in baking. And in recent studies, it's been used for tissue engineering as well as medical uses. In this study, I'm going to create sodium alginate hydrogels mixed with phosphorus powder in order to see the effects of it on the germination rate of radish seeds, which are commonly used and grown in the world. So the question is, what is the effect of increasing phosphorus concentrations in sodium alginate hydrogels on the mean length and number of radish seeds that germinate after 2 days? And my hypothesis is that the radish seeds grown in hydrogels with higher concentrations of phosphorus will have a higher germination rate in terms of the amount germinated as well as the radical length. So my variables are my control, which has 0 added phosphorus, 0.25% added, 0.50% added, 0.75, and 1 whole percent. And then my dependent variables will be the number of sprouted radish seeds, as well as the length of the radicals. The control variables is the volume of the sodium alginate, the amount of radish seeds, the germination time, the hydrogel concentration, the temperature, humidity, and room temperature as well. Materials are analytical scale, a medicine cup, 750 radish seeds for the total of 25 trials, 100 milliliter beakers, a phosphorus powder, a graduated cylinder, a glass stirring rod, distilled water, petri dishes, a digital caliper used to measure the radical length, calcium chloride, as well as sodium alginate. So to create a sodium alginate hydrogel, you need two parts, the cross-link solution as well as the sodium alginate solution. For the cross-link solution, you prepare the specified amount of calcium chloride dihydrate and mix it with distilled water. For the sodium alginate solution with phosphorus, you pour in the amount of phosphorus needed as well as the sodium alginate powder, mix that together, add distilled water, and then you're going to take your petri dish, pour in your crosslink solution, and then you're going to pour in the sodium alginate on top of the crosslink, and for 5 minutes you're going to like gently stir it, not stir but shake the petri dish once every minute for the 5 minutes, and then you should be left with a solid sodium alginate hydrogel with the different amounts of phosphorus. And then for the experimental procedure, you're going to place the 30 radish seeds spread out through each petri dish, and then for the data collection, oh well, you wait 48 hours. And then for data collection, you're going to measure how many seeds sprouted as well as the lengths of the radicals. So here's a picture of before and after. And so the number that germinated was 14.6 in the control, 17.2 in the 25%, 20.8 in the 50%, 26.2 in the 75%, and 29.4 in the 1% on average. Here's a chart with the standard deviation and the form of error bars. For the mean lengths of the radicals, 0.71 millimeters in the control, 1.43 in the 0.25%, 3.57 in the 0.50%, 6.98 in the 0.75%, and then 12.20 millimeters in the 1% phosphorus. So as you can see in the chart, again, there's a increase in the lengths when you increase the phosphorus concentrations. And then I did a ANOVA test in order to see if there was a significant difference. Because the F value is greater than the F critical value, that means there is a significant difference. And then furthermore, I did a Tukey honest significant difference test to see if there's a significant difference in between each treatment. And after solving it, there is a significant difference in between each treatment. So in conclusion, the presence of higher concentrations of phosphorus in the sodium alginate hydrogels means the germination rate will be higher in both in terms of the germination seeds that sprouted and the lengths of their radicals. And there's also a statistical significant difference between each mean radical lengths of the radish seeds. And applications, hydrogels they can be reused often in nature. So you can make this once and then use it for quite a long specified a time. And then that reduces the amount of water you need in order to germinate radish seeds. Now, this can be applied to any seed. I just use radish seeds because they are commonly grown in many places. And with the new climate that's happening, where it's getting hotter, places will start to dry up. So, using these sodium alginate hydrogels in the soil itself will allow you to use less water over time in order to grow your plants. And for further improvements, I would like to use different ratios of phosphorus and find one where there's no significant difference between that one and a slightly a smaller amount in order to create cost efficiency. I'd also like to use different nutrients such as nitrogen and potassium. A similar study using different types of hydrogels such as anabana beads or even um, simple like hydrogels, and then also the different like concentrations of sodium alginate to produce the hydrogel. So that's like the thickness and the viscosity. You can either go thicker or thinner. And yeah, and then here are my references. Thank you so much.